and we want to know where that is, and we can use mass links to at least get compositions here. And we also can get the sites because we know the molecular weight of the fragments, the peptide fragment, and we know from our previous analysis what sugars could be attached to that fragment. So if you use the software, you can do a site analysis on erythropoietin. You also, sometimes it's easier to do a site analysis if you use ABS. You take the silated structures off, and because you get a simpler profile. So this is the profile showing you the sugars at asparagine 38, which are desilated sugars, and this structure here is a fragment that's come from asparagine 24 site and so on. So if you get more complicated glycan analysis, this is the kind of thing that you would do. This one is telling you that these very long lactosamine extensions are most likely going to be at this site, which is has this peptide here, peak 24 or peak 38. And again, this is using the mass links to identify glycosylation sites which are carrying glycans so that you can penetrate those more easily. And the other important thing with EPO is this O-link glycan. So the same thing, you do a triplet, an peptidoglycanase digest, and you identify these different diagnostic ions for different types of sugars. I'm running out of time, so I'm just going to show you one last thing, which is this is the characterization of the occupancy of the O-glycan site in erythropoietin. So this is using a combination of collision-induced dissociation and ETD, and this technique breaks up weak sugar bonds, and ETD breaks the peptide backbone. So if you use a combination, you can identify the sugars that were at this peptide site, and by using CID, and then you can decide which sites they were attached to using ETD. So with erythropoietin, it's very easy because there's only one O-link site, and there are very small sugars there, just these tiny core 1 structures. I'm not the time to show you, but if you go into etanercept has an enormous number of, it has 2 domains with 13 O-link glycans on each. So using a combination of CID and ETD, you can decide which glycans are present on which site. So that's state-of-the-art paper we did with Waters. I think there's probably only one other paper that's attempted to do that. So that's where the cutting the front edge is in all of this work. So I'm going to stop because I'm running out of time. So thanks very much for listening. And any more questions? We've got 4 minutes.
So since somebody is also using the auditorium and we don't want this to come as last as yesterday, if you would like just to dedicate some more minutes,
yeah.
And we can go to Aula 2 and just for a question and answer session. So do you know where the Aula 2 is? And we'll convene there in 15 minutes to give us time to get a card to break
yes,
up.
Okay.
And we'll convene there just for like 15
yeah,
minutes.
But anything.
I'll be back in 1 second.